Namaskaram everyone. Welcome back to the 66th episode of Master Unreal series, and in this episode we are going to start building the shop system which is inspired from God of War Ragnarok or the God of War before that one. Okay, so I have posted the spoiler already. If you haven't checked it out, just go ahead, and otherwise I think one must be playing in my background right now. So we are going to build this exact same thing where you will have your shop. A shop can have multiple merchants. A shop can be approached by NPCs, which can be the customers. And if you have seen our interaction system episodes, I will relate the exact implementation with these smart objects. I will tell you that your attention and your focus that you place in those episodes, it will give you the results right now. The thought process that you developed in those 6 or 8 episodes of interaction system, you are going to see how the Unreal Engine's developers or engineers exactly mimicked the same system in the smart object and how they made it more modular and decoupled. Okay, so in this episode, I'm also going to shed some light over there, and I'm sure this will give you the confidence of working like a AAA developer, or let's say you are understanding the thought process, how the games are developed. Okay, so I'll show you the exact same thing in the smart objects. And apart from that, we are also going to use state trees, which we left last time. So if you haven't seen the previous episodes, I highly recommend, because we have built the foundation in a very good way. So without wasting any time, let's get started. Okay, so let's pay attention. Let's see how we will make this NPC to NPC, NPC to player, player to NPC interaction with this shop example. So we have two entities, customer and merchant, on the shop. So first of all, let's imagine it like a real world situation. What happens in the real world when we want to get an item from a shop? First of all, the customer goes to the shop. Then the customer tells the owner what he wants. Then the owner instructs one of his helpers to check and get the item. Now, this owner can be a physical entity, or it's just your own simple brain, which tells you, hey, you need to interact with that helper to ask and get the item. So the owner, the system, or a physical entity instruct one of his helper to check and get the item. For example, if the item is not there, then he should deny it. But if the item is available, let's focus on that happy path first. The item is available, he gets it for you, he placed that item in front of you on the table, and then the customer takes the item. So what are the key entities in this use case? So let's decrypt these highlighted words, which are the entities. I need a customer who can buy stuff. Then I need an owner or a system that can tell this helper or someone else that what to do once you receive a request from this customer at this shop. Then I need a helper who can do the job for me. So these are the 4 major tasks that we have taken out from this particular use case. Okay, so let's focus on these 4 points and let's derive what we have to do as a developer in the code base. So your customer is your NPC, okay, which is your AI character, which you have already created in previous episodes of Smart AI. And then you need a shop. So shop is an interactable. Now, so far, we have been using an interface which makes any actor, or let's just say this way, if you want to become interactable, then you have to implement that interface. So that is a small pattern that you use to identify what is interactable. But now we are taking it one more step further by using these smart objects. First of all, interactable interface will tell the system or will tell the NPCs or player that this thing is interactable. It can be anything. Now, the smart object is one of the features from the Unreal Engine. So it's their internal systems that they have exposed in the editor that allows you to make the interactable work more simple and modular. So what was happening earlier is that you create a shop actor and then you place your entire logic. How does the interaction happens, what to do, what not to do when the player comes, what to play, what animation to play. Then after the animation is over, then we call the merchant. All that was happening in the shop actor. So that means you were bloating the shop actor. And that is what Unreal Engine's systems are doing. They're just making your actors more and more lightweight. Now, when we will do smart object, I will explain you. But so far, you have observed in the interaction system, we were placing everything in that interactable's blueprint. If it was a bench, you were placing it there. If it was pushing the cabinet, everything was happening there. Your hand placement, you are pushing the block, you are playing the animation, you were instructing to go to a specific position before you push. Everything was happening in this shop blueprint, which was making it more and more heavy. And that is what Unreal Engine don't want you to do. They want you to use their own systems which are designed and integrated in an efficient manner so that it supports your gameplay design. Then you need an owner which can tell what to do. So I will address this specific part in the next slide. Then you have a helper, that is your merchant in the shop, which is going to do the actions when you will request. So let's take the God of War example. Okay, so we have a perfect situation here. Okay, I will say this is my customer. Now, this customer can be the player, which is controlled by a controller, and it can be an NPC as well. Now, this is your shop counter. So, this is the entire space, and in this space, there is this actor that blocks you and tells you that this is the place where you interact. So, first of all, you implement the interface for the player to tell what is interactable and what is not. And then this interactable has a smart object component which tells NPCs or the systems that are going to control your NPCs that this is where you have to come. So they are not going to go for your interactable interface. They are going to go for the smart object component. I will show you how this smart object will provide you all the features that you have built in the interaction system. And I'll tell you how they are much more efficient, how they are decoupled. Okay, but let's go further. Then there is this helper or the merchant. Okay, now your shop can have more than one merchant to serve you. If it's a big shop, NPCs can also come. So one merchant is attending one NPC, another merchant is attending you as a player, or the merchant is attending to some different NPC. So the idea is one shop can have many merchants and it can have slots for many NPC or the customers or the players. Then there is this entire subsystem which is a brain of your gameplay mechanics that is dedicated for interaction. Okay, so this is going to tell the NPCs. Let's say the NPC feels like from the inventory they get a need that they do not have the item. Let's say they do not have the equipments, they do not have a rifle, they need to get a rifle as a soldier. So the need will tell the subsystem, hey, I need a rifle because that need was generated from my inventory system. So the subsystem will entertain the need of the NPC and it will direct them to this smart object, which is the shop counter. And once they come here, the smart object is going to tell them exactly how they have to interact with this actor and to get what they want. There is one more thing. This merchant is not a person. Technically, it's an occupation. It's a skill. It's a quality of the character. It is not the character. Okay? Brock right now is a merchant, but in one of the missions of God of War, he takes you to a space where you get a spear from that creature. Okay? So he was not merchant at that point. He was a fighter. He was a soldier at that moment. Okay, so this is a quality. This is not the character. So do not create a merchant actor or character in your game. That's a big mistake because then you will be stuck with the inheritance. What we want is merchant is a quality, so that means it will be an actor component. So you can remove it and add it. That means you can make anyone merchant, and anytime you can remove it and make them something else. Okay, so this is what we call as composition. So when we are doing gameplay design, we rely more on composition than inheritance because composition makes things decoupled and you can remove or add it whenever you like. But inheritance is a lock. It's a it's a constraint on your design. Okay, so never go for inheritances such situations. Always ask yourself what is actually the thing and what is quality of that thing. Okay, so let's go to Unreal Editor and I'll show you how this smart object is simplifying your stuff. So this is the shop that we made in level design episodes, and I also want you to have a look at this bench use case. Right now this bench can only have one person, but if you extend it, then there is a space for 2 to 3 people, right? I'm just illustrating the scenario. So at this moment, what you were doing is that everything was happening in the event graph or in this particular actor. Like someone comes, there is an interactable interface implemented, they interact, they hold, then you first position them to that particular slot, and then you play the montage to make them sit, and then you start listening for the movement input. As soon as the movement input is pressed, you make them get up. So this is what you were doing in this particular actor. Now what smart object will do, it will provide you the same room but a detachable and a isolated style. So let me show you. First you need to go in edit, plugins, smart objects, and enable the gameplay behavior and smart objects, and restart. So once you restart, you can close this, and now I will go to my architecture folder and I will create wooden shop table. Okay, and I'll open this up, and what I'll do, this is my counter, so I'll remove this. This is my counter. So what I'll do, I'll create an actor, b underscore wooden shop table, save it and open it up. And in this, I'm going to add the static mesh. I'll say SM table mesh. So I'll say shop desk. Okay, this is my actor, and I'm going to place it right here, and I'll rotate it by 180 degrees, and I'll place it exactly there. So what I'll do, I'll copy the location and I'll select this, and first of all I will delete it and I will paste it here. So this goes exactly to the place where I want it. Okay, now in the wooden shop table, you will first of all make it interactable. So class settings, and we are going to use BPI interactable. So now you have is available to interact and the on interact. And when your trace hits, you can highlight the bench and you can say like trade or purchase or something like that. So compile, and now I am going to add the smart object. And now we will select the smart object and we will create the definition of it. So select and go to architecture, wooden shop table, and I will say SOD shop counter. Okay, this is a counter. So save it and you got the definition. Now what you can do, this is the editor window of this smart object. So how do you represent it? This is the preview settings. So you can use this to see how you should place your slots and everything. I'll tell you. But the actor is our shop. Okay, so now you got your wooden shop table right here. And I'll increase the static mesh table height by, let's say, 20. Okay, I think for now this much is fine. We just need to see both the sides. Okay, so this is your shop table, and now I can collapse this. Here you have slots. So the merchant will be standing here and the customer will be standing here. How you used to do earlier with me in the interaction system was in the viewport, you used to create this position to start. So whenever someone interacts first, they have to arrive at this position and then they will start playing the animation. The reason of doing that is because we want them to sit in center. And if this bench goes big, then we will create one slot here, so that they can sit here and here, right? So that's exactly what we did in blueprints, but now this smart object will allow us to do it in this small environment, and it will be loaded in the memory as per the demand. So how do we do that? If you go in outliner, you can add the slots. So I'll add the first slot and I'll say this is my Let's expand it. I hope you are able to see the details. So I'll name this slot as merchant. All right. And you can see if you select this merchant and you bring it here. So this is the position where the merchant has to come before they start interacting with this smart object or the interactable. So earlier you were doing that in the actor. Now we will do that here. So you see Unreal Engine, the developers have simplified our needs into this small little environment for us. So merchant has to come here, and if it's a customer, then it will come here. You don't have to create the scene components to store the transforms. Okay, that is the first enhancement. You see how they are improving their thought process. Before this, in the series, we never did smart objects, and the way we approached it is exactly same as the smart objects are doing it. So focus on learning the thought process and you will find all the cool systems of Unreal Engine automatically very easy to understand. Okay, so merchant has to come here if he wants to entertain the customers. Next up, we want another slot that is for my customer. So I will go in none and I will change this to customer. Okay, I will bring this. Now there is this arrow. This is the facing direction. So what I'll do, I'll rotate it. Okay. So for example, in case of bench, you had position to start, and in this, you were facing in this direction. However, if you go to cabinet, you were placing your X towards the cabinet. So this is how you were determining the rotation. So that's what exactly they are giving you in this particular space of the slot. So right now I'm just considering single merchant and single customer. If you want, you can create more slots. Like this is the center slot. You can add one more slot. And let me first of all, my shortcut keys are not working here. That's too bad. Yeah, so you can position the second slot here and the third slot here like this. So this can be center. I can name it customer center. Okay, and this can be customer left. This can be customer right. You can also make 3 slots for 3 merchants right here. Okay, so it's all up to you. How do you make your smart object? So I'll delete this for now. I do not need it. I just need one customer interacting with the merchant and one merchant serving the customer. Now here's the thing, both merchant and customer are the NPC. Before we go and classify them as merchant and customer, both are NPC. So no one should be able to claim this place which is reserved for a merchant. Okay, so this slot should only be for the NPC that is doing the merchant work. Okay, so what I'll do, there is this user tag filter. There is this enabled, which means this slot is enabled. That means any merchant that is there in the shop can claim it. And this customer center is also enabled, which means any NPC can become the customer for this shop. So this is the first parameter, and these are some basic metadata of this slot like name, color, size, and all that. Next is the user tag filter. So what you can do, you can use the gameplay tags. So what I'll say, all tags match. That means I'm only giving the slot if you are a merchant. So we have to create that. So what I'll say, smart object dot user dot merchant. Okay, so this particular slot is reserved for this merchant. So I'll add this tag. Okay, and I'll select it. Now it says user tag filter. So if you are searching for a slot that is for merchant, then this slot will be selected for you. I'll tell you how this selection will work, but first I want you to understand that this slot is for the merchant. Now let's go for customer. Now anyone can become the customer, but we will create a tag, and in this one I'm going to add a new, that will be smart object dot user dot npc. That means any NPC can be the customer. Okay, even a merchant from another shop can be the customer for this particular shop. So I'll say this and add. Okay, and we also need the player, because the player can also be the customer. So we will do one more thing, smart or what you can do is just duplicate this and remove this NPC and make it player. Okay, add. So select these two tags. So we will change this to any tags match. Sorry, let me select them back. NPC and player. Okay, so every AI character is an NPC, so it will search with this tag, and if it's a player, then it will search with the player tag. But if you are a merchant, if an NPC is a merchant, then it will search with the merchant tag, not with the NPC, because if we make it exposed to NPC, then any customer can become the merchant, which we don't want. So we'll press OK. So this is how you use the user tag filter, which will be used in the system to figure out which slot as the NPC they should take. Okay, then you have activity tags. Now remember, if you go to gameplay ability that we created to interact with the interactables, this one. So whenever you used to execute or interact with the specific interactable, you used to call this interactability. And if you go to class defaults, you used to assign interacting tag. Now why? Because if we go to BP player and search for event take, you see if you are interacting, if your player is interacting, then you should not do the trace at that time. You should only look for interactables when you are not interacting, when you are moving freely. But if you are not, then in that case, you want this interacting tag to be present so that other actors can read it or your own system can read it. So for this, they have provided us the runtime tags. Okay. So what you can do in the runtime tags, you can look for interacting and you can put this. So as long as they are doing this interaction, whatever you will do, you will assign this runtime tags. And as soon as the interaction is over, this tag will be removed. Okay. So this is for NPC and your player again. I'll do the same for customer as well. Okay. This is our way to identify whether they are interacting or not. Again, this is temporary. You can change your tag namings, but for now, I'm just considering this. Now, there is one more thing, conditions and data. I'll cover this in later episodes. First, let's get comfortable with the normal happy paths of using this smart object. So I'm skipping these two and we go to the last part, that is behavior definition. So let's say if it's a merchant or if it's a customer, they will take this slot. Now after they arrive here, what do they have to do? Because in case of bench, you were sitting. In case of cabinet, you were continuously pushing once you arrive at that scene component. You see, once the player is ready, you used to get the skeletal mesh, you used to update the IKs, and then you used to start the box push animation, right? So now you have to tell what you are going to do when you are going to come to this point. So we will add the definition for merchant first, and there you have this gameplay behavior smart object definition. Now this is one way, but we want to use the state tree approach. So what I'll do, I'll go and edit plugins and I will search for interactions. Now you can see gameplay interactions, player and NPC. I'll check it. I'll say yes. I'll save all and restart. Okay, once you restart, you can reopen your editors. So now we will use the gameplay interaction smart object behavior definition. This means you are going to use the state tree approach. This means you are going to go for behavior tree or a separate task like blueprint. So we are not going into that. We are not going for behavior approach. We are going for interaction approach. Don't worry, in the later stages, I will introduce them. But so far we have migrated from behavior tree to state tree in the last episodes of Smart AI. So I will stick to interaction based behavior where you can plug in the state tree. Now, what was happening in the bench? You were doing everything in this actor, which means your actor was becoming heavy. Now, what you can do, you can put that all logic in a state tree and you can attach it and load it into the memory in runtime based on the requirement. So your data is in the disk and it will not come into the memory unless you are here interacting with it. Okay, so we need the state tree. So what we will do, I will go to this architecture wooden shop table. I'll save it. It's okay. It will show you warning because you have not provided the behavior. And I'll go for artificial intelligence state 3, and in this you will find this gameplay interaction state 3 schema. Do not go for state 3 component or AI, just go for gameplay interaction state 3. This has little extra supporting features. I'll show you. First select it and we'll say state 3, and I'll say trading. Let's call it this way. Okay, this is the trading graph which is meant for the merchant, and now you can select this and plug it here. Okay, you can see it auto detected your tree. Great, this is for merchant, and now you will create a tree for the customer. So I'll duplicate this one, control D, and I'll say st customer trading. Okay, and let's rename to st underscore merchant trading. This is much better. Okay, so I'll go to customer center, and in the behavior definition I'll add interaction behavior, and I'll plug my customer trading. Now you can save. Okay, no warnings. Awesome. So you have defined the behaviors that will go in these slots. Now what you will do, you will open this merchant trading first. Now you can see this is giving you this schema where you can provide the context actor, smart object, and it is also giving you the information of the slot. Okay, so your smart object is all over ready. Now let's bring our merchant. So what I'll do, I'll go in blueprints, AI, characters, and you see you have been deriving your characters from the BPAI default, which is right here, and you are deriving that from character default. So this is the inheritance that we have did so far, and now you can derive all your AI characters, be it your enemy, NPC, and everything. So what I'm going to do, right click on this AI default, create child, and I'll say, and let's call it James. So this is our merchant. Okay, so I'll move this to characters, move here, and now we have to replace our mesh with the character. So let's import the character which I gave away on 2000 subscribers. You can collect it from Discord. It's absolutely free. So this is my James character. I will import the FBX, and let's go here and replace the skeleton with SK mannequin and import. We'll go for CH06 body, and first of all we will use the diffuse map. So let's select the diffuse, and then we go for shiny, that's your glossiness. Then we go for normal map, and yeah, I think this is it. Let's also have a preview here, and I'll open the James character. Okay, and let's bring him down 90 degrees. Let's make it minus 89, and let's increase the capsule's half height. Okay, I think this much is good. Great, now we need to get done with the shoes. I will open this and select the diffuse color map 1002, put it shyness, the glossiness. Then we need normal, so go for normal. That's it, right? Yeah. Okay, so this is it. Save all. Let's see the James again. Oh, what happened? Something is still not connected. Save, apply. Yeah, now the James character is fully textured except the eyelashes. Let's have a look here. We need the diffuse color map. I would use the same. We need the normal map. Okay, so let's save again. We have the specular pin as well. So what I'll do, I'll go for this specular and I'll remove this. I'll duplicate this normal map and I will rename it to specular map. And I'll connect this RGB in specular map. And we are going to replace this with the CH06. Okay, that's for eyelashes. Let's also do it in body. What I'll do, I'll copy this node go to body and paste it here, delete this one and connect it with this. Save, apply, and go to CH06, paste it here as well and delete this specular, connected with this, but this time we have to change this to 002 because these are shoes. Okay, so these are the shoes. Now let's have a look at the James character. Now they're absolutely fine. Okay, so eyebrows, shoes, and everything, it's good. Compile, save all, and now we will place our merchant. Let's go to characters, blueprints, AI characters, and I'll place the James here. So now you have your merchant. Let's save all. Okay, so after placing this, you have your shop counter ready. Now thing is, you can have different type of shop counters. For example, this is for this particular shop. And if you remember the 1K subscribers giveaway, we had this shop. Let me open it up. You see this one. Now in this situation, this big block could be the shop counter. So you are not going to copy all the logic from one shop counter to another, and you do not want to do inheritance as well, because inheritance means locking down things which we do not want. So what we'll do, we'll create an actor component that will contain all the shop counter logic. And what I'm going to do is create a component which is called shop counter. So I'll go in tools, new C++ class, and we are not doing it blueprints right now. So we'll go for this and we will say shop counter. Okay. And this is going to be in the first person game. Create a new folder, call it components. And inside this, we will paste it. Okay, so you might be getting a warning. Click on reload all. Okay, great. So this is our shop counter component. Now, first of all, let's remove this prefix because shop counter is present in the same directory. That is one. And I'm going to go in the header and you can see it is blueprint spawnable. So what I'll do, I'll go back to my old level. That is your maps, merchant, third person map, sorry. Hit the live coding so that we can compile the changes. You can create actor component in blueprints. It's absolutely fine. But we are now transitioning to C++ and you will also have subsystems and everything. So they will need access to this class, which we cannot do if we make it blueprint. Okay, so now you can go to wooden shop and add the shop counter. Okay, so there you have your actor component. Now first thing what do you want is every shop counter will have certain set of merchants. You will assign them, okay, in your level editor. So I will create a variable and expose it. So I will go for public and I will create a variable actor pointer and we will say merchants. And now here's a catch. This is your shop counter, but I told you merchant is not a person. It's a quality. It's an occupation of that particular character. So that means we will create an actor component that will support the merchant functionalities again in C++. So I'll go to tools, new C++ class and actor component, and I'll name it merchant component. Okay, and I'll place this under my components, select folder, create class. Okay, and now go back, reload all, and there you have your merchant component. So remove the components and in the header we are good. Cool. So we will file and save all. Go back to our third person map, hit the live coding again, and we will go inside our James character that we just imported here. And in the James, sorry, this is skeletal mesh, my bad. I should go to characters in AI under James. And in the full blueprint editor, I will add this merchant component. Okay, great. So save and compile. So that's it for this video. I hope you enjoyed it. You do let me know if you have any comments, suggestions, thought, feedback, or any questions in the YouTube comment section or on Discord. The link is in description and you can collect all the assets, characters, animations for free from Discord. Feel free to join. And I was getting a lot of requests in last couple of weeks, I think, that we are exceeding the time durations of the episode. So I decided to cut it short back to 30 minutes. So in the next episode, we will complete the shop actor component and the merchant component, and we'll see how they will communicate, and then we will plug them into the state tree. So in this episode, I gave you a higher level overview of what are the components or elements or entities that will be involved in this entire shop system. Now in the next episode, we will implement their logics. So stay tuned. And if you like my work and you want to support me, the Patreon and the coffee link is in the description. We support both one-time and membership option. Just have a word with me on Discord before buying any membership. So I'll see you in the next episode. Till then, you take care. Bye bye.